Good morning, good afternoon, good evening, whenever and wherever you are. My name is Anna Rochelle, and today we are going to talk about how to write an equation of a line for a both parallel line and a perpendicular line to a given point with another line that we are actually given. So we're actually going to go ahead and do 3 different examples in this video, so brace yourself. Some of them may be a little bit less challenging than others, but the idea is the same with all 3 examples. The very first thing that we're going to need to do is we're going to need to find the slope. And before we find the slope, we're going to need to remember that parallel lines actually have the same slope, right? And then perpendicular lines, they have negative reciprocal slopes. So when I say negative reciprocal, I mean reciprocal. Oh my gosh, I can speak and write and talk and everything at the same time. And speak and talk is the same thing. Awesome. Okay, so when I say negative reciprocal, I mean that if something is negative 3/4, the negative of negative 3/4 is going to be positive. And then the reciprocal of 3/4 is going to be 4/3, right? So that's what I mean by negative reciprocal. And same is obviously like if it's going to be 1/2, it's going to be 1/2, right? And this would come from my original equation. So whatever the slope would be would come from my original equation. So for example, when I'm looking at this very first equation right here, I'm looking at this negative 3/5. Negative 3/5 is my slope. Whoops, not what I wanted. So I wanted negative 3/5 as my original slope. And when I create lines that are parallel, I'm going to use the same exact slope. And when I create lines that are perpendicular, it's actually going to be different. My perpendicular line is going to go from negative 3/5. It's going to become now positive 5/3. Okay, nothing else in this equation makes any difference to me whatsoever. I could care less about anything else in this equation. This is the only piece that I'm looking for, okay? So let's get started. The best and easiest way that I can recommend that you write a new equation is using point slope form. Now, point slope form is actually really helpful because it gives you a point in the equation and the slope. And if you're not asked to write the equation of a line that's parallel and perpendicular, you can absolutely use this point slope form and leave it in point slope form. Like if you're asked to put it in standard form, obviously you'll have to do some adjustments. But for the most part, I haven't really seen very many of these like specific directions. It has to be in slope intercept form. It has to be in standard form. It's usually like just write the equation. Okay, so since this is my point slope form, I know that I'm going to go ahead and I'm going to replace every single time my x and y point and my slope. Everything else is going to stay as is, so I can kind of have like a shell of what I need, right? So it's always going to be x minus equals open parentheses, oh, whoops, that was supposed to be y minus. And then that's it, right? So everything else I'm going to go ahead and replace. Now I know that what I'm going to replace is my slope. So my slope is going to be negative 3/5 for a parallel line. And I also know that this is the point that I'm going to use in order to create my new equation. So since we have x and then y every time in a coordinate point, I'm going to put -1 in here and 5 in here. Now, one thing that I would do in order to simplify it fully is to have this negative go away and then leave my equation as is. Again, if you would like to, or if the rules tell you, or if, if the directions say put it into slope intercept form, then go ahead and just get y on its own, okay? Now, the way that we're going to do perpendicular line is literally the same exact way. I'm going to go ahead, I'm going to leave the same exact pieces empty. Whoops. And then I'm going to go ahead and I'm going to replace everything with the same point, right? So I'm going to put -1 in here and 5 in here, and I forgot that minus, okay? And then I'm going to put in my new slope, and my new slope is going to be 5/3. And ideally, I would get rid of this double negative every single time. And here we are. This is a perpendicular line. Whoops. Perpendicular line. Okay, and so they're both of those lines are going to pass through this point. So we know that they're going to be perpendicular to each other at this particular point. So they're going to create those 90-degree angles. Okay, let's take a look at another example. So in here, we're actually starting off with standard form, kind of. Really, we shouldn't have negative in standard form. So our goal is going to be to create this equation from standard form to slope-intercept form so we can get our slope very easily from here. So when we go from standard to slope-intercept, we're going to go ahead and we're going to solve for the y. We're going to get y on its own. So in order to do that, I'm going to have to add 6x to both sides. Now, remember, I can't add 6x to -1, so I'm just going to leave it as is. And now I can determine that my slope is 6. So for my parallel line, I'm going to have a slope of 6. For my perpendicular line, I'm going to have a slope of -1/6. Because that's the negative reciprocal of 6, okay? That's going to be my new slope here. Again, in both cases, I'm going to use my shell of, point slope form. And then I'm going to replace all the things that I need to. Again, for perpendicular form, I'm going to use my shell again and replace everything that I need to. So if I were to take a look at this piece here, this 1, 7, 7 would go here, 1 would go here. Again, 7 would go here, 1 would go here. And then the only difference would be my slope, right? So my slope in here would be 6. And then my slope in here would be -1/6. Now, and for this example, I do want to go through and I want to go through the motions of actually creating slope-intercept form for both of them. So we can actually go in and say, okay, y minus 7 is equal to 6x minus 6, because all I did was just distribute this piece. And then I'm going to go ahead and add 7 to both sides. And I'm going to end up with y equals 6x plus 1. And this is my parallel line. This is my parallel line. Okay. Now, taking a look at the perpendicular line, when I fully distribute, I don't want you to freak out because there's a fraction. It's totally fine. In fact, we usually prefer fractions for slopes, right? Because we want to know our rise and our run. I'm going to go ahead and still add 7 to both sides. And I'm going to end up with y equals -1/6x plus 7 and 1/6. Totally fine to leave 7 and 1/6 as is. No big deal. Perpendicular. Oh my goodness. It's like I've written this only once in my life. Okay. Now let's take a look at another line altogether. So in this case, we do have an endpoint slope-intercept form. However, we do have a 2 attached to our y, so we're going to try our very best to get rid of it. So what I'm going to do is I'm going to actually divide each term by 2 to get y equals 2x minus 3. Now it's very easy to determine what my slope is. My slope is going to be 2. And I'm going to go ahead and I'm going to say, okay, my parallel line, whoa, that's incorrect. My parallel line is going to have a slope of 2. And then my perpendicular lines are going to have a slope, whoops, of -1/2. Okay, so these are the two things that I'm focusing on. All right, so now again, I'm going to go in and I'm going to use my point slope form. And I'm going to replace my x and y and my slope. So I'm going to do y minus 5 equals 2, x minus -2. So again, I really want to make sure that I get this -2, double negative. It's just not cool, not okay. So we're going to simplify things. We're going to make 2 and then x plus 2 in here. And then let's turn this into standard form. So I'm going to start off by distributing. So I'm going to end up with y minus 5 equals 2x plus 4. I'm going to actually bring this up here. I don't need it that high. I'm going to have y minus 5 equals 2x plus 4. I'm going to add the 5 to both sides. And I'm going to end up with y equals 2x plus 9. Now, in order to have something that's in standard form, I want to have ax plus by equals c, where my a and my b are both whole numbers. So we don't want fractions, which is fine here because we don't have any fractions. But we also want a to be a positive number, okay? So in order to get x and y on the same side, I'm going to move the x over to the other side. I'm going to subtract 2x from both sides. Now, if you recall, I cannot have x and y added together because they're different variables, right? So after that, I'm going to go ahead, I'm going to take a look at my coefficient for x, and that's negative. So I don't want that. And because I don't want that, I need to actually divide everything by -1. Some teachers will say multiply everything by -1. It literally means the same thing. There's no difference. So I'm going to have 2x minus y equals -9. And that's my equation of my parallel line to this original line in standard form, okay? So we're going to do the same exact thing for perpendicular lines, right? And this is just the sign for perpendicular lines. Obviously, it's going to look more accurate in your textbook, but you get the idea. Okay, so I'm going to start with y minus 5 equals -1/2 x. Again, I know that it's going to be plus 2 because it's a negative, and I just always want to take the opposite of that. And then I'm going to go ahead and I'm going to distribute. I'm going to get -1/2 x minus 1, right? Because half of 2 is 1. And this is a negative. I'm going to add my 5 to both sides. Now, in this case, when I do want to create a standard form, I do have an issue where this is a fraction, right? So what I'm going to do is first, I'm going to go ahead, I'm going to move it to the other side by adding 1/2 x to both sides. And then I'm going to see that it's already positive, which is great news for me. But then I'm going to multiply the entire equation by 2 to get this into a whole number, okay? So I'm going to distribute 2 to every single term, and I'm going to end up with x plus 2y equals 8. And that's where I'm going to be able to get my a perpendicular line to my original line and passing through this particular point. I hope this video was helpful. I'll see you in another video. Bye.